So welcome to Daniel Shakespear, our next speaker. Daniel Shakespear is an automotive engineer with over 20 years experience in the industry. Currently, he is employed at BMW in Munich, working in the field of vehicle concept development, programming in numerous languages and application development have been part of his work throughout his career and already a hobby since his school days. The topic of his presentation is Interactive Genealogy Explorer, visualization of migration of ancestors and relatives. Please, Daniel.
Okay. Thank you, Frau Venz-Hauptfleisch, for the opportunity, and also Dr. Rohlberg. As Frau Venz-Hauptfleisch mentioned, I'm not a professional genealogist or archivist, but in my spare time, I've developed a visualization which might be of interest or inspiration for some of your work. So I'm happy to talk to you about it today. A few years ago, I started inputting into a traditional genealogy tool, my family's genealogy along with that of my wife. And I noticed that there are a variety of ways that genealogies are represented. Obviously, there's the traditional family tree, which shows all lineage and parents all the way up. This can be shown also in circular form, which is the nice graphical representation but doesn't really provide any additional information. Both of these forms don't allow showing siblings, so you can do that in this sort of a form, but then you lose the nice symmetry and visual appeal. For more complex genealogies, which involve reading across generations and the like, or large data sets, there is something called Genealogy, which is shown here. And families are sort of in these 45-degree lines this way and individuals that way. And then very recently, after I started working on my project, a company called RootsMapper has provided a way to show some geographical information for migration. So if an individual migrated, say here, to Argentina or to the U.S. or to Europe, it's shown as a line. As I put the data in, the only visualization I was able to get out of the tool I was using is here. But I wanted to see something a little bit more. My family and my wife's family comes originally from Europe. My ancestors spent a good deal of time going back and forth to India for military reasons. And I came up with the idea that it would be interesting to visualize these individuals in space over the Earth with the different events in their lives as data points over the geographic location. And then that's basically what you see here. Time is represented both by the altitude of the event and also by the color. So the very oldest entries are on the left end of the visual spectrum here in this sort of violet. And the very newest entries are down here in orange. That's my nephew going to Cambodia and back to Boston there. In order to do this, I'll talk briefly about the technical details here, hopefully not long enough to make you wish we had our coffee break yet. But I started in a regular commercially available tool, putting in information. And obviously, in order to do this, it's necessary to have not only the date, but also the geographical location. You can't plot something on the Earth if you don't know where it's happened. The interactive genealogy viewer is then used to parse the data and provide the visualization. Unfortunately, it's quite a bit more complex than would be convenient for a typical user, but I'll talk through how it was done here in this first form. Once you have a genealogy input, and then you export it in the GEDCOM format, which is this de facto standard in the industry for genealogy information, it goes into a CAD program, Google SketchUp. Basically, in the left column here are commercially available programs. In the right are external web services. And the three things in the middle are the parts of the project that I wrote that provide the geometry. In the CAD program, the user is asked through an HTML window. It reads in the GEDCOM file and it asks which individuals do you want to produce. After that's selected, then there's a location lookup over geonames.org. It's an AJAX service. You provide a city name and it provides latitude and longitude back if it finds it. And then Google SketchUp begins to produce these various shapes for each individual. Those are exported in DAE format to a web server running locally on the machine. And Google Earth, using the Google Earth plugin, which is deprecated now and will not be available for very long, I've been told, then provides the globe and reads in as needed the various shapes with the events. So that's the overview. Here's a couple of pictures from the process itself. This is the window where the user selects the GEDCOM file and can pick which individuals he or she would like to see plotted. You have to do the generation of geometry only once. Once it's been generated, then the viewing is considerably quicker. After this selection and geonames lookup, the CAD program creates the various lifelines. Here's a view of a couple of panels from the viewer side. Once you've generated the geometry, the user can then pull up the viewer and interact with it a little bit more friendly format. There are selection controls whereby you can either pick an individual by name or look for all individuals after a certain date or a person and their ancestors, etc. Or you can try to find a path between two people who are related. If they're fourth cousins, how do you go up the tree and down the tree from one person to the other? And then with the click of the update button and a little bit of time, Google Earth provides an image like this, and it's just as if it's a normal Google Earth interface, so you can spin around, zoom in. In this table here, you can click from event to event in an individual's life, or go to their mother or father, and also do other things to make the Earth spin or whatever, at the usual Google Earth functions. Here's a couple of examples. This is some selected data to show the color span from the oldest entry, John Shakespeare of Shadwell from 1619, down to the newest, which again is my nephew going to Cambodia and back. This is me moving to Munich a few years ago. This is the entire set of data. There's about 200 visualized names there. Not very easy to do much with, but it shows you sort of in an overview how much data is in this particular genealogy. And it also gives you an idea of when people migrated where. Here you see the people going back and forth from the UK to India, exploring in Saudi Arabia, a couple of migration paths. This was the third cousin moving to the US in the 1800s, and my great-grandfather moving to Argentina in the late 1800s. Again, not very useful from a direct standpoint, but as an overview. Here's an example of a path. My third or fourth cousin, Dorothy Shakespeare, lived in Italy up until her death a few years ago. Never met her, didn't even know I was related until I did the project, but she's in the list now. And this shows then the connection between the two of us. There's a video on this. So the video doesn't run, but it was to show the process of walking through an individual's life, where you can start with their birth and go from event to event. And Google Earth globe rotates around to the right spot, and you can zoom in and see, to the accuracy with which you put in the information, where the event happened, at least as the planet looks today. So things have changed in the centuries. All right, so some initial results and issues. Discernibility of names is not very good, especially if you have a lot of people, one altitude. Here was a family that came over and had several children. What I ended up doing there is implementing an algorithm that looks for spatially close names and then spirals the angle so that you can at least make out a little bit more of the information. And the interactivity that Google Earth plugin allowed is very minimal. What I was able to do is use place marks, which you can put on a map, and they're clickable. But you can also put them in space. So here are little flags, which if you click on that, you'll get a little bubble with the initial of the person or persons involved in that event. You can click, and then with some luck, it goes to that event. But again, this is a limitation of the current implementation. It's not very much interactivity. Also, initially, I had different color schemes, sometimes using the names as the driver of colors or just random colors selected per new last name. That made it very difficult to determine the time because from a 3D perspective, it's hard to get a sense of the altitude. The other issue we had initially was from space. If you think about looking at this individual here or this individual here, it's pretty hard to tell that that's directly above this part of Europe. So I added these small white lines down to the surface, and that seems to fix that problem. Other issues or limitations, this is the genealogy of David Cameron, his connection to William Makepeace Thackeray, the famous author. Most of David Cameron's immediate ancestors were born, lived, and died in England, so they sort of pile up here in a column. And in cases like this genealogy visualization is not as interesting as in other cases where there's a lot of migration. But the colors and spacing do help you at least differentiate. So, comparison to other visualizations, it's very difficult to compare it directly because it has different purposes. The other visualizations are very good for quickly identifying by generation who's related to whom and connections between people, but it doesn't provide any geographical information. And also, at least to my knowledge, they're all done, or the majority are done by generation and not by year. So when you have a large data set with families expanding over multiple generations, it's difficult to tell if this person's fourth cousin lived at the same time as this person's. Comparison to Roots Mapper, this is a very nice online system launched in fall of 2013. It's much simpler to put data in, but it provides also, as a result, a much simpler visualization. There's no time indicated here, just where people came from and their gender. And obviously this would get very, very cluttered with a large data set. Some observations and personal learnings. It helped me to identify and sort of visualize the ancestry, myself and my spouse, and put in perspective when and where people came from and where they've headed to. And we also found some connections we hadn't known. A third cousin of my brother's lived within about 150 kilometers of him for several years of his life. That family line came over from India directly to the U.S., and we had lost touch with them, the branch of my family that came through Argentina. So we had a chance. We haven't gotten back in touch. He's passed on, but at least we know that through our lifetimes there were people in the U.S. Related from that side of the tree. Limitations, obviously, you know this better than I do. With any visualized data, the quality of the conclusions you reach is as good as the quality, or can never be better than the quality of the data you put in. Looking at the visualization you've seen, it looks like a lot happened between England and India. Reality is that's 1/8 of my heritage, and if I look at that and think of that as my heritage, I miss out on the other sides of it from Europe for which we don't have records. So that's one limitation. As we saw with David Cameron, if people don't move around much, it becomes a little bit less visually interesting. You do need to have places for things. There's really no way around that. Place names, as we've heard today, are not always immediately identifiable with latitude and longitude coordinates, especially as you go back in history. And finally, the visualization at the end is correct geographically, but it's correct to today's boundaries in political areas and structures. So you have to take it a little bit with a grain of salt in that regard. The Google Earth plugin per se has a lot of limitations in interactivity. It's also going away. I'm looking at a replacement called Cesium, which is open source, but I'm just beginning to play with that a little bit. Would love to consolidate it into a one-step solution that took a GEDCOM file and gave you a visualization. That's probably not possible even with Cesium, since that requires a local web server, but I'll see how that works out. And parsing of additional GEDCOM events and allowing you to show subsets of events and the like, and not the entire file would be good. Some ideas that came from this that may be of interest in your areas would be really nice to have a scalable, translucent globe that had morphing boundaries. So if I wanted to see the world in 1850, I'd have a globe at the 1850 altitude that effectively shaded or hid, not completely, but mostly the people and events from newer times, and sort of highlighted who was where, when, and what was happening, and had the correct boundaries for the countries. That would be, I think, a useful addition. Don't know how to do it technically, but I'm sure somebody does. Another possibility, if you think about rather than visualizing an individual, visualizing groups of individuals, you could do that with variation of the thickness of the lines. For example, you could plot developments in a war with shapes which morphed from large to small as groups went to battle and lost troops or gained troops from other areas, and create sort of a 3D visualization of what happened over time in a set of battles. This is probably better done on a flat map rather than a globe, given that most of the battles and the like take place in smaller areas. And it would probably also require some kind of a sectioning function or a translucent, scalable, movable layer that lets you look at a specific time and say, I want to see the battle of XYZ which took place at this time, and you could go to that and see it. And then another idea would be to use similar 3D shapes of varying size to show the migration of humans. And we could show interaction between Homo sapiens, Homo neanderthalis, and the like. Or essentially, you could use a visualization like that to show the diffusion of information as well, the influx of language, how language is spread, or how people move throughout the world. So those are just a few other ideas that came up. Again, I don't have technical solutions for them, but if they're of interest, it's something to think about. And then if you have additional interest, I've got a paper printed. There will be a link in the files, and there's a couple of videos online that you can see of the actual tool. And if with a little bit of luck, I may be able to get it running on my tablet later if I can connect back up to Wi-Fi here. Any questions?
Thank you very much. The discussion is open.
Thank you. It's really an embarrassing project. In our project, with Jester and Gary, we are making summaries of medieval charters of kings and emperors, and we have about 100,000 data sets of dates, place names, and the king's name. Do you think it would be possible to visualize the way of our kings in the medieval ages with your tool? Is that possible? Is it accessible?
How many individuals do you have? You have 100,000 data points?
Yes, but individuals, how many individuals? 15.
I would.
20.
It theoretically possible. I would really recommend we look at reducing the data set a little bit so that we don't track every movement of the individual. For example, when I was doing this, largely out of getting tired of typing, I stopped putting in where my brothers went to college when they went away for 3 months or 6 months. And, so with that sort of a parsing and data limitation, it could be done. And that can be done automatically, too. You could look at the time duration between movement, and if you have someone go somewhere and come back within a period of time, ignore the move.
But this can be done automatically?
Yes. Yeah, I don't have the tool written for it, but you can do that directly in Excel. There is an intermediate step where the parser exports a CSV data set, which you can then process in Excel if you want. So.
I'll come to you in the call.
Okay, great.
Other questions or comments?
I have one question and maybe one answer for you.
Okay.
So first the question. I have a similar question like Mr. Kuchera, and I would like to ask, if I want to plot only one person's movement,
yes,
could I then use big data?
Theoretically, yes. If you'd have to write the tool to retrieve the data and put it in a format that this tool could use, or we write some other interface. Essentially, you can understand clearly what's needed is the individuals, the location, and the time. Right. With that information, it can be done.
I would be interested to go down to the day level.
Yeah,
I don't know if graphically it would make sense, if this would mean anything to the viewer then.
It's tricky. It depends, too, on how far apart the locations are. If you have things happening in a smaller area, I think rather than a spherical coordinate system, it would be better to just use a traditional XYZ coordinate system. The tool's not set up for that currently, but it would actually be easier to do than what's been done. So, and the way the tool's set up now, it does go down to the day level. The input is number of days from whatever your reference date is.
Okay, so my comment and maybe an answer for your question, you asked about translucent globes.
Yes.
So I don't have translucent globes, but I have translucent maps. That would be interesting for you.
Okay.
Where you can overlay different maps from different time periods, and choose which one will be on top and below, and slide the transparency from 0 to 100.
Okay. Good. Yeah, that could be useful. Yeah. Okay. Thank you.